one broke, but so sometimes when I'm using the Smart Notebook software, there's some glitches, like tiny triangles just popping up for no reason. So it can help you go just a little bit faster on the ACT. You can also just set up regular trig. You could say, like for this one, you could say cosine of 45 equals cosine of 45 equals 7 over x, and you could solve that with trig. So you can do it that way. That way is going to require a calculator, and it's going to take a little bit longer, but you can do it that way also. But this is a shortcut. It can help you on ACT. It's also going to help us on what we're going to do today. 30, 60, 90 triangles are a little bit more difficult because they've got a little bit more going on. But like if we had a triangle that looked like this, and they told us this was a right angle, and that this was 30 degrees, and they told us this side right here was 4, then we would know automatically this side right here would be 8. We would just take twice the short leg, right? And then this side right here, it would be 4 square root of 3. So if they were asking for those, you would know them really quickly. If you had, you might get something like this. So this is 60 degrees. They might give you something like this. They might tell you this side right here is 3. So this time they didn't give you the short leg, so you got to get to the short leg before you can get the hypotenuse. So to get from short leg to long leg, we multiply by square root of 3. What would we do to get back to the short leg? Divide. So I'd have 3 over the square root of 3 here, which they're probably going to actually rationalize that. So they'll probably multiply by square root of 3 on top and bottom, giving you 3 square root of 3 over 3. 3's cancel. You just get square root of 3. So answer will probably be rationalized there. Or if you don't want to rationalize, just type in the calculator. You'll get the same value as square root of 3. And so if this is square root of 3, then the hypotenuse would be 2 times the square root of 3. So those shortcut rules for those special triangles, the 45, 45, 90, and the 30, 60, 90, they can be helpful in just helping you do this a little bit faster. These are actually kind of useful in real life as well, because a lot of things that we deal with have these sort of dimensions. So like it is very possible that you might be making something that is square and for some reason needs to know the diameter. Not diameter. You don't have diameter of a square. The diagonal of the square. And so rather than having to do Pythagorean theorem or something like that, you could just know automatically one leg times the square root of 2. You also, it's just very common to have these dimensions right here as well, and where you would have these sort of angles, so you would know how to do that a little bit quicker. I know that my husband was building a dog lots, and he had to put a door on it, and the door was square, and he was wanting to brace the door with a diagonal brace, so I could immediately tell him that he's going to take the length and multiply it by square root of 2, and that gives him how long his diagonal needs to be. So something that you possibly could use, probably not every day, and you can get around not using it, but it might be helpful to you somehow. Make you faster at math, so if you want to be a math teacher, you can impress your students one day. Impress your children one day whenever they have to take this class. Still remember it, I'll be impressed. My grandpa, he's a smart man. It's been several years ago, but I had a cousin, he was taking Algebra 1, and I was helping him with his work over there at his house. My grandpa was there, and my grandpa he was probably like 75 at the time, and he had not had algebra for probably 60 years, and he could still factor a quadratic, and it had been that long since he had had it. My mom is an accounting major and, of course, had algebra a lot more recently than him anyway. And she couldn't do it. She could not do it. But my grandpa, he could still do it. I was pretty impressed with him. And, most grandpas probably didn't even really take algebra. You didn't really have to. Especially, like, my grandpa's age. He's 82 now, I think. So, 70 years ago, they didn't make everybody take algebra. So, you impress somebody if you remember it. All right, let's get to our notes for today, though. So, we are going to be doing, we are going to be completing a unit circle. And, in fact, I'm going to go ahead and give you your copy. Is a circle with a radius of 1 that has its center at the origin. Okay? So, this circle right here has a radius of 1. So, that would mean this point right here is at 1, 0. Here we've got 0, 1, negative 1, 0, and 0, negative 1. And on this circle, I have drawn in a line right here and labeled this angle right here as 30 degrees. Now, what is the length of that line that I've drawn in? It is the radius, and what is our radius for the unit circle? It is 1. And it's called the unit circle because 1 unit is the radius of the circle. Okay? So the length of this side right here is 1. Okay? So what I want to find is I want to find the coordinates of this point right here. Alright, so I'm looking for the coordinates of this point. And so if I want to find the coordinates of that point, I could do this. I could make this a triangle right here, and that would be a right triangle. And I'm going to call this side right here X, and I'm going to call this side right here Y. And the reason I'm calling them X and Y is because from 0 over to here, that's the length of X, so that'd be my X coordinate. And then from the X-axis up to here, that is Y, and that would be my Y coordinate of that point. Right, so if I graphed X, Y, then those are the coordinates of this point. Now, this is a special right triangle, which is why I went over that at the beginning. So if this is a special right triangle, then we've got 30, 60, 90. We know the hypotenuse. We want to find the short leg, which would be the Y right here. So if we think about that 30, 60, 90 triangle, what would we have to do to find it? Kason? We would divide by 2. So Y would equal 1 divided by 2. Okay, so my Y coordinate is 1/2. And then, now that I know this side right here is 1/2, what would I have to do to get X? I would multiply it by the square root of 3. So X would equal 1/2 times the square root of 3. And if I want, I could put this over 1, and that would give me square root of 3 over 2. So the X coordinate right here is square root of 3 over 2. So the coordinates of this point right here are square root of 3 over 2 and 1/2. Okay. Now, so we would ask ourselves, why in the world do we even care about what those coordinates are, right? This is why. All right. If I find sine of 30, ignore tiny triangle that showed up. All right. Sine of 30 degrees. I would do opposite over hypotenuse, right? So that would be 1/2 over 1. And so 1/2 over 1 is just 1/2. So sine of 30 degrees equals 1/2. Now, that doesn't mean that much to us, but if we were ancient mathematicians who didn't have a calculator, we would really want to know what sine of 30 is, because our calculator would not tell us it is sine of that it equals 1/2. So that would be helpful if we were solving trig functions. So this y coordinate right here gives us our sine value. And we also want to know this because if I do cosine of 30 degrees, cosine would be adjacent over hypotenuse. And my adjacent side, that was square root of 3 over 2 over the hypotenuse, which is 1, which is just square root of 3 over 2. So if we were an ancient mathematician that did not have a calculator, the unit circle would tell us that cosine of 30 is square root of 3 over 2, which would be helpful since we would not have a calculator to give us that magic number. Okay, so if you'll look at that blue sheet that you got there, let's add what we've just found to this sheet. Let me zoom back out so we can see it here. Okay, so if we found, I'm going to label this right here as, yes, oh, sorry, yes. So if we, this angle right here, this was 30 degrees, and we found that right here at this point, the x-coordinate was square root of 3 over 2, and that the y-coordinate was 1/2. And so when we use the unit circle, your x-coordinate is cosine. I'm going to use a theta right here for the angle. You guys seen theta before? It's like a 0 with a line, horizontal line through it. And then the y-coordinate is sine of theta. So if I want sine of 30 degrees, I just look right here, 30 degrees, sine, y-coordinate equals 1/2. Okay, I'm going to go ahead and put a couple more points on here. This point right here, since you have a radius of 1, that means this right here is 1. This would be positive 1 right here. This would be negative 1. And this would be negative 1. So the coordinates of this point, they'd be 1, 0. And the coordinates of this point would be 0, 1. Coordinates of this point would be negative 1, 0. And the coordinates of this point would be 0, negative 1. And actually, I'm going to do this so that I don't get them mixed up. I'm going to move my 30. I'm going to put my 30 degrees kind of out here because putting all of, once we put all the angles on here, they might get a little mixed up. Okay, questions so far? Okay, let's go figure some other stuff out for this. Alright, so the next circle that I've given you here, it's still a unit circle. Now I've drawn in a line right here, but I've got a 45-degree angle. Right? And so I'm going to make myself a right triangle right here. And I'm going to call this side right here X. And I'm going to call this side right here Y. And Leah, what's the length of this slanted line right here? It'd be 1 because that's a radius. Right? So in this case, I've got 45, 45, 90 triangle. Patrick, what would I do to find the X? We'll divide by the square root of 2. So we'll take 1 and divide it by the square root of 2. But the rulers of the mathematical kingdom say that we can't leave the square root in the denominator. So we're going to multiply by the square root of 2 on top and bottom. And if we do that, we get square root of 2 over 2. So x would be square root of 2 over 2. And if x is square root of 2 over 2, y has to be square root of 2 over 2. Also because this triangle is isosceles, so we'll have square root of 2 over 2. So let's add this to our unit circle. So on that unit circle, we'll have, let's look back in a little bit so I can see a little better. So right here, this is 45 degrees, and my x coordinate is square root of 2 over 2, and my y coordinate is square root of 2 over 2. Okay. All right, we've got one more we're going to do, and then it's going to be a lot easier to fill in the rest of that unit circle. So this one right here, I've got 60 degrees. And so if I make this a right angle right here, I know this side is 1. I'm going to call this side X, this side Y. And so this is also a 30, 60, 90 triangle. So to get the length of the shorter leg right here, I just take the hypotenuse and divide it by 2. So X is just going to be 1/2 right here. So the X coordinate is 1/2. And then to find the Y, I'm going to take the short leg, which is 1/2, and multiply by the square root of 3. So Y is going to be 1/2 times the square root of 3, which I can put over 1, so it's square root of 3 over 2. So square root of 3 over 2. You'll notice that this is just switched from the 30-degree angle because it's really the same triangle, it's just turned a different way. Okay. All right. So, in a second, we're going to go back to our unit circle, and from here, we can just use logic to fill in the rest of the whole circle. Okay. And I'm going to show you how I do that. So, we just found this was 60 degrees, and so this is the, let's see, this is 1/2 and square root of 3 over 2. Okay. All right, questions so far? All right, so you have to have this first quadrant memorized. If you don't have this memorized, then you won't be able to do any of the rest of the unit circle. When I give you the unit circle quiz, now you can't have like 3 hours to take it, but you'll have a little, might have 10 minutes to take it. So you can think about it a little bit. You don't have to just be able to write it down like a robot really quickly. You can think about it a little bit. So you have to have this first quadrant memorized. After that, you can pretty much figure everything else out. The other thing I don't have on here is I don't have radians on here. I'm going to add this right here. This is 0 degrees. It's also 0 radians. Or I could call it 360 degrees, because if I go all the way around the circle, I'd end up right back here at 360. Or I could call it, what would 360 be for pi, for radians? It's 2 pi radians. Okay. Now, yesterday we found out that this over here, we know this would be 180 degrees, half of 360. We also know it was pi. Okay, this is how, now there's several different ways to memorize the unit circle. There's like a trick with your hand that I can't remember. There's like songs and rhymes and all kinds of things. So If you don't like the way I'm showing you how to do this, just go give it a quick Google, and there's a YouTube video that will show you some other way that might make better sense to you. But let's see, I want the highlighter. Okay, this is what I think of. I split my unit circle into 30-degree increments. So if you kind of go around your unit circle and you're looking at every 30 degrees. Like this. I like that one too. And so you're splitting this into 30-degree segments. Notice it just skips these angles, these 4 numbers right here. So this is going to fill in most of the unit circle for us whenever we do this. So this is 30 degrees, this is 60 degrees, this would be 90. You'd add 30 more, you'd get 120. You'd add 30 more, you would get 150. You would add 30 more, you'd get 180, which we already knew, right? Add 30 more, you get 210. Add 30 more, you get 240. Add 30 more, you get 270. Then 300. And then 330. And then you're back around to 360. So that fills in all your degrees except for just these few that we're missing here. So that's helpful. What is 30 degrees as radians? It's pi over 6. Because if you think pi is half the circle, right, we split it into 1, 2, 3, 4, 5, 6 pieces right here. So 30 degrees equals pi over 6. So this is what I do for my radians. Now I'm going to go back and reduce some. But if this is pi over 6, I'm going to do the same thing I just did. Now some of these I need to reduce. I'm going to do the same thing I just did with that 30, 60, 90, 120, 150. I just added 30 all the way around, right? I'm going to do the same thing with pi over 6. I'm going to have pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. This is 6 pi over 6. I'm going to write it down right here. Although it's going to reduce, right? 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and 11 pi over 6. Now, some of these I don't want to leave like that. Because 2 pi over 6, what can happen to it? 2 over 6 reduces to 1/3, right? So I'm going to take this 2 pi over 6, and I'm going to reduce it to, I'm going to erase it. I'm going to run out of room if I don't erase it. I'm going to change that to pi over 3. So once you do that, once you count around pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and so on, you need to reduce anything that'll reduce. So like right here for 3 pi over 6, 3 over 6 reduces to 1/2. So that would be 1 pi over 2. So pi over 2 for that one. And then 4 pi over 6. That reduces to 2/3. Come on, eraser. So that would be 2 pi over 3. 5 pi over 6 will not reduce. You'll leave it alone. 6 pi over 6, it's pi. We already had that written down because we knew that one. 7 pi over 6 will not reduce. You'll leave it alone. 8 pi over 6 will reduce. That's 4 over 3. So that's 4 pi over 3. 9 pi over 6 will reduce. 9 over 6 will reduce to 3 over 2. So we will have 3 pi over 2. 10 pi over 6 will reduce. That's our last one. So 5 pi over 3. So 5 pi over 3. So this covers most of the unit circle whenever you do that. Now, there's lots of other ways you can memorize things. If it makes more sense to you, do that. I don't like to memorize things. I'm not that good at it. It just doesn't come naturally to me to memorize things. So I like to come up with tricks to help me remember things, or just logic to help me figure it out even if I don't have it memorized well. So we've got that. Let me put this back here. Questions so far? Alright, so then what I go through is I go through and do the same thing, but with 45 degrees. So this would be 0, this would be 45, this would be 90, then another 45. So you notice some overlap here. So for 45 degrees, if half of the circle is pi, if I look at these blue sections, what is 45 degrees in radians? It is pi over 4. Because it's a little bit difficult. If I could get rid of all of that yellow without erasing the other stuff I have there, I would. But you've got this blue section, this blue section, this blue section, and this blue section. So you took pi, which was half of the circle, you cut it into 4 sections. So this angle right here is pi over 4. So we're going to do the same thing with this that we did with the 30 degree angles. So if this is 45, this is 90. If we add 45 more, we're going to get 135 right here. If we add 45 more, we'd get 180. If we add 45 more, we get 225. Add 45 more, we get 270. 45 more will give us 315. And then 45 more would give us 360. Or those aren't hard to figure out because halfway between 30 and 60 is 45. There. But pi over 4, if this is pi over 4, this would be 2 pi over 4. But that reduces to pi over 2, right? And then this would be 3 pi over 4. And this would be 4 pi over 4. This would be 5 pi over 4. This would be 6 pi over 4. And this would be 7 pi over 4. And then 8 pi over 4 would be 2 pi. Okay, so that fills in the rest of those units there. I'm going to erase some of this because 2 pi over 4 reduces to pi over 2, so I don't really need that. 4 pi over 4 erases the pi, I don't need that. And 6 pi over 4 reduces to 3 pi over 2, so I don't need that. Okay, questions so far? We are almost there. The last thing that we need to remember for this is in the first quadrant, my x coordinate is positive and my y coordinate is positive, right? In the second quadrant, x coordinate, is it positive or negative? It is negative. What about the y coordinate? Positive. What about third quadrant down here? Negative, negative. And fourth quadrant, positive, negative, right? So if you're, and this, remember this is your first quadrant, this is the second quadrant, this is the third quadrant. This is the fourth quadrant. I'm not going to ask you that much, but there's something that might show up on the ACT that you've forgotten from earlier classes. So if I take this point right here and I flip it over here, it's going to be the same point except for the x coordinate is going to be negative. So I have negative square root of 3 over 2, 1/2. Same thing, if I take this point right here and I flip it over here, it's going to be the same coordinate, but the x coordinate is going to be negative. And right here, I'm going to have 1/2 square root of 3 over 2, but that x coordinate is going to be negative. If I take this point right here and I flip it over the y-axis, it's going to be the same point, square root of 3 over 2, 1/2, except for which coordinate is going to be negative? The y, that negative 1/2 right there. And so right here, I'll get square root of 2 over 2 and negative square root of 2 over 2. And right here, I'll get 1/2 negative square root of 3 over 2. And then, same thing happens down here. If I take this point and I flip it over, I'm going to have negative square root of 3 over 2, and I'll have negative 1/2. Both coordinates are going to be negative there. Right here, I'll get negative square root of 2 over 2, and negative square root of 2 over 2. And then, right here, I'll get negative 1/2, and negative square root of 3 over 2. So if you know that first quadrant, you can figure out the rest of the unit circle. Now, I've spent quite a bit of time kind of showing you this because I want you to understand sort of how it's working, how it works just like fractions. With all of these are just fractions of the circle, how the symmetry works and all of that. So this you need to be able to do, right? We will probably do Tuesday next week is when we'll have our unit circle quiz. You have to be able to fill in this blank unit circle by Tuesday. Okay, now all of it, everything including the cosine theta, sine theta up here. Now this should be an easy quiz for you because you guys can memorize this, right? Yeah, let me, there you go. So you guys can memorize this. I know it's kind of a lot, but as we practice it more, I think you guys will get better at it. I also will post, I'm going to save this one right now so that it's filled in. Oops, sorry. Let me save this one right now so it is filled in. I will post this, and I will post the blank one. So if you want to print some off and practice them, you can. You can also just Google unit circle and find a bunch of these. So by Tuesday, we have to be able to do this. Now, let's look at what we use this for. You can skip. We're going to skip that. We did that yesterday. Oh, I'm running out of time. All right. Let's see. I could go on a long explanation of this, but I'm not going to because we're running out of time. You may or may not have learned this before. Tangent of theta. We know it equals opposite over adjacent, but it also equals sine of theta over cosine of theta. Alright, so secant. Have you guys seen secant before? Okay. You may or may not have seen secant depending on what you've done with this. But secant of theta is 1 over cosine of theta. case you're wondering, it is also, like this is opposite over adjacent. This one is also a hypotenuse over adjacent. We won't need that today, but you could possibly need it sometime. Cosecant is CSC. So cosecant of theta is 1 over sine of theta. And cotangent of theta, which, look at that, that's hypotenuse over opposite. And cotangent of theta is cosine theta over sine theta, which you could also say is adjacent over opposite. Now, we don't really need the adjacent opposite stuff for what we're doing right now. We need this sine, cosine. Now, a couple of things that you definitely need to know: tangent is sine over cosine. So it kind of makes the other three are what we call reciprocal identities. What does it mean to have a reciprocal? It's not opposite. Opposite would be like the negative of something. It's flipped, right? So the reciprocal is just the flip. So cotangent is the reciprocal of tangent. So if tangent is sine over cosine, cotangent is cosine over sine. Secant is the reciprocal of cosine. So whereas cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. So it's 1 over cosine. And then cosecant is the reciprocal of sine. Now the way I remember it, tangent obviously goes with cotangent, right? Those two just sound alike. It sounds like secant and cosecant should go together, but they don't. Secant and cosine go together. Cosecant and sine go together. I remember it because a co has to be with every pair. So secant cannot go with sine because there would not be a co in that pair. Secant and sine don't start with co. Cosecant can't go with cosine because you'd have two cos in that pair, and that can't happen either. So secant has to go with cosine so that there's a co in that pair. Cosecant has to go with sine so that there's not two cos in that pair. So these eventually you're going to have memorized also, but just not quite yet. Okay. Now, the reason that we need this is because we are going to use our unit circle to find trig values, and the unit circle does not tell us sine, cosine, tangent values. So let me see if I can get this where I can see both of these here. Okay. All right, so here's how you use the unit circle. So first you must pretend that you're an ancient mathematician and that calculators do not exist and you cannot type this in on the calculator, and that you don't want decimals. That might be a stretch for most of you, but you have to. Then, if I want to know sine of pi over 2, I would look at my unit circle, I would find pi over 2. So pi over 2 is right here on the unit circle, right? And sine, is that my x-coordinate or my y-coordinate? It is the y-coordinate, because right up here we wrote that sine was the y-coordinate. So if I want to know sine of pi over 2, I just look right here. Pi over 2 is right here on that unit circle. And the y-coordinate of the point that goes with that is 1. So sine of pi over 2 equals 1. Yes, you would only give the y-coordinate if it's asking for sine. Okay? So if you look at number 2, it's asking for cosine of 5 pi over 6. So 5 pi over 6 is right here on your unit circle. And we want to know cosine. Cosine is my x-coordinate. So I'm going to go over here to the point that goes with 5 pi over 6, which is right here. And I'm going to give just the x-coordinate. So that would be negative square root of 3 over 2. So if I'm an ancient mathematician that needs to know cosine of 5 pi over 6 for my mathematical studies, then I know that value without having to have a calculator. Okay? All right. Let's see. Let's stick to only things that are on the unit circle today. So negative pi over 3, not on the unit circle. I'm going to skip it for right now. We're going to go over it tomorrow, mostly because I don't want to rush through explaining that since we're about to run out of time. 3 pi, not on the unit circle. I'm going to skip it. 11 pi over 2, not on the unit circle. I'm going to skip it. 3 pi over 4, that is on the unit circle. So if I'm looking for sine of 3 pi over 4, I'm going to find 3 pi over 4 on my unit circle. It's right here. And sine of 3 pi over 4 is right here. Or 3 pi over 4, sine is the y-coordinate. So use the y-coordinate right here. I get positive square root of 2 over 2. Okay? All right, now let's look at the tangent of pi over 4. Pi over 4 is on the unit circle. It is right here, right? But does the unit circle give us tangent? It does not. So what you have to do for this is the reason I just showed you those other trig identities. To do tangent of pi over 4, we're going to have to do sine of pi over 4 over cosine of pi over 4. And I do know sine and cosine from the unit circle. So from the unit circle, when I look at this, Raphael, what is the sine of pi over 4? Square root of 2 over 2. Right, that is my y-coordinate. And then cosine of pi over 4, it's also square root of 2 over 2. So square root of 2 over 2 over square root of 2 over 2 is 1. Okay. Number 8 is secant of pi over 2. I can't find secant from the unit circle, but I can find 1 over cosine of pi over 2. And so if I look at the unit circle, pi over 2, I'm looking for cosine. Sydney, what do I get for cosine of pi over 2? Is cosine your x or your y coordinate? X coordinate. So cosine's x coordinate, pi over 2 is right here. So what's the x coordinate that goes with that point? 0. So it would be 0. Oh, that gives me a problem. What's 1 divided by 0? It's not 0. Undefined. Remember, this is why I want a calculator that's going to give you electric shock every time you try to divide by 0. Then you can remember undefined really quickly. And so this is sort of the idea. Now, let me see if I can find one real quick. Let me do 9 real quick. I know I'm running out of time. Cotangent is cosine over sine, right? So if I go to pi over 6, I got to do cosine over sine. So that would mean the cosine is the x-coordinate. That would be square root of 3 over 2. And then sine is 1/2. Oh, I don't want to leave it like that. That looks terrible. What do I have to do when I have fractions over fractions? Split the second and multiply. So I'd get square root of 3 over 2 times 2 over 1. Those 2's right there can cancel, and I just get square root of 3. Okay? Yeah. Or you could write square root of 3 over 1, but you don't have to put it over 1.